Bismillahirrahmanirrahim. Waxaan noo socday chapter 3 transformation geometry. Waxaan soo qaadanay qaybtii koobaad vectors. Maanta waxaan qaadanaynaa marka qaybta labaad translation, reflection, rotation and enlargement. Learning outcomes. By the end of the lesson, learners should able to state properties of translation, state the properties of reflection, properties of rotation, and enlargement. Now, we'll start with translation. Now, first of all, to transform, the word transformation is from the word transform. So transform means to change. To change. Now we change either the position, or the size or the shape of an object. Now the first shape before the transformation is known as the object. After the transformation is known as the image. Now there are four basic types of transformation. We have a reflection, a translation, reflection, rotation, and enlargement. Now the first three, the object and the image, they are always of the same size, meaning the object and the image are always the same. Now what we change here is only the position. What changes is the position. But for the enlargement means increasing or decreasing the size of an object by a scale factor. You can either increase or decrease the size of an object. Now from the table there we have transformation is categorized into two. We have changed the position and changed the size. Changing the positions, these are the changing positions. We have the translation, reflections, and rotation. And then changing the size is the enlargement. Now today's lesson will be starting a translation. Translation. Now translation means movement. Translation means movement in a certain direction. Movement in a certain direction. Certain direction without turning. Certain direction without turning. Now with movement means you can move the object either to the right, to the left, up or down. There are three basic types of translation. We have the horizontal movement, that is the horizontal translation. We have the vertical translation and the oblique translation. Now from the table there we have the first shape is known as we have the original, and then which is the object, and then we have the image. Next, in the example below, there is a triangle there. The triangle is translated to become triangle A, is translated to become triangle B, and therefore A is moved horizontally. There is that horizontal movement. There is no movement vertically. The object is moved to, like for example, this is the triangle. This is the triangle. The triangle now is moved from A and then to B. There is now that movement horizontally, that is. Now the first shape is the object, and then the second shape becomes the image. Then, now let's start now the properties of translation. One property of translation is all the objects move. All the points move. All the points move in the same distance and in the same direction. The same distance and in the same direction. Another property of translation is the object and the image are directly congruent. The object and the image. The object and the image are directly congruent. They are directly congruent. Now the word congruent means they have the same size and the same shape. That is, the same size and the same shape. For example, this triangle, this one fits triangle B. So this is they are directly congruent. That is what translation means. Now, for example, I said translation means movement in a certain direction. So therefore, I'll be drawing a triangle, and then I'll move the triangle either to the right, then upward. Let's say we have this triangle. We have 1, 1, then 1, 3, and then 2, 1. So we have that triangle. That's a right angle triangle. I want to move this triangle and then horizontally and then upward. Now you're told to move the triangle 2 steps to the right and then 1 step up. We normally write translation in form of column vectors. That is x, the first one is x, the second one is y. So I want to move this triangle 2 steps to the right and then 1 step up. For example, if you move 2 steps to the right, A will be point A prime, so this will be 3. So this will be my A prime, and then 2 steps to the right and then 1 step up. 1 step means plus 1 up, plus 1 up. So this will be where A prime will be. This is A prime. Then B prime will be 2 steps to the right. You will move to 2 plus 2, which is 4. And then 1 step up. 1 step up meaning plus 1 step. So you'll move to point. That is where B will be. And then C, 2 steps to the right. That is 1 plus 2. You'll get to 3. And then 1 step up, you'll reach 4. So 1 step will be 4. So this will be 2 steps to the right, 2 steps, and then 1 step up. So this is C prime. Then you join the points. Now you can see we have this triangle. Now the object and the image will be of the same size. We will normally use graph paper to draw the object and the image. Now if you join, for example, the points B to B prime, then B to B prime will be 2 steps to the right and then 1 step up. That movement is known as translation. A very simple way of doing this one is you just say image is equal to object plus translation. Image is equal to object plus translation. You will add now, you say A prime will be equal to the object, which is 1, 1, plus the translation, which is 2, 1. Therefore, you get 3, 2. You can see now we have 3, 2 there, which is A prime. The next one is B prime. B prime will be equal to 2, 1 in form of column vectors, plus the translation, which is 2, 1. And then you get 4, 2. 4, 2. That is where 4, 2 is. And then C prime will be equal to 1, 3. So you add the translation, which is 2, 1, and then you get 3, 4. So you can see now the object is moved to this one. So therefore this becomes the object and this one becomes the image. So that movement is known as translation. The movement is known as translation. For example, if you want to find the image, sometimes you might be asked to find the translation. You'll be given the object and the image. For example, now this movement is known as the translation. You only count. You count the boxes here, or what you can do is you can just use the formula. You say translation is equal to image minus object. You only make the subject T, and the next one will be O will be equal to I minus T. So that is now the introduction for the translation. The next one is reflection. Reflection. Reflection is the second type of transformation. is a second type of transformation. The word now reflection is a transformation that flips a figure across a line. Or we can use the line, therefore, is the mirror line. So reflection is a type of transformation that reflects object through a mirror line. Now from that flip, that one is, you can see we have the object and then the image. Now let me write also the properties of reflection. Assume this is the object. Assume this is the object, and then this one is the image. This one is the image. We have the object and the image. We have the object A, B, C, D. Let me just call this one A, B, and then C, D. Therefore, this will be A prime, B prime, and then C prime. Therefore, this one becomes D prime. So meaning, now first of all, one property of reflection is the object and the image are always the same size. Meaning, the object and the image are of the same size. They are of the same size. The other thing is, the distance from the object to the mirror is always equal to the distance from the mirror line to the image. So you can see now this distance will always be the same. The distance from the object to the mirror will be the same as from the image, from the mirror to the image. So if this is 2 meters, this one will also be 2 meters. And then the mirror line becomes now, it will be a perpendicular. They will be perpendicular to these two. So meaning each will be 90 degrees. Each will be 90 degrees. Another property of reflection is, like translation we said, translation is directly congruent. This one becomes indirectly congruent. Indirectly congruent. Indirectly congruent meaning here, if you raise up your hand, your right hand, then the image will raise, for example, the left hand. So that is laterally, we call them laterally inverted. Laterally inverted. Laterally inverted. So that is what that point means, indirectly congruent. Okay, another point therefore is, another characteristics for reflection is the image, points on the object are invariant. We have what is known as the invariant point. Invariant here means fixed point, invariant. Invariant is the same as fixed. Now let me start by giving example on reflection in the x-axis. Reflection in the x-axis. Reflection in the x-axis. That is example number 1. Reflection in the x-axis. Now let's take a point. Let's say we have a point A and then B. Now this is my object point. This can be a triangle, it can be a rectangle. I'm just picking a point. So let's say this is my point, and this is the mirror line. This is where your mirror is. So this is now the reflection. You want to reflect this point under the x-axis or across the x-axis. So what happens is the A will be invariant. A meaning fixed point, because there will be no movement in A. So what happens is B comes there, here. So this is minus B. So A, so if the object is, for example, AB, then the image will be A minus B, because we said that A is invariant because the reflection takes place at this particular point. So therefore, A will be invariant. Invariant means fixed, meaning there will be no movement in A. So that is reflection in the x-axis. Reflection in the x-axis. This is the general formula for reflection in the x-axis. Okay, reflection in the y-axis. The next one is reflection in the y-axis. Reflection in the y-axis. Reflection in the y-axis, meaning you will place your mirror line here. So meaning B becomes fixed, because B, there will be no movement in B. So what happens is A moves to this particular point. So this will be where minus A will be. So the formula for reflection in the y-axis, if you have the object AB, then the image will be minus AB, minus AB. X changes the sign, then B remains the same. So that is what reflection in the line in the y-axis means. The next one is reflection in the line y is equal to x. Reflection in the line y equal to x. Reflection in the line y is equal to x. Y equal to x means when x is 1, the value of y is 1. When x is 2, y is 2. When x is 0, y is 0. That is what reflection, the line y equal to x means. Now, I'll be drawing that line. So this line means y is equal to x, meaning when x is 1, y is 1. When x is 2, y is 2, and so on. So therefore, let's say you have the point A and B. Now, one property of reflection is the mirror line reflects on both sides. The mirror line reflects on both sides. Now, if this is your mirror, if this is the mirror, then A moves to that particular point, and then B moves to this particular point. They interchange position. So therefore, reflection and the line y equal to x will be, if that is the object, then the image will be a BA. BA, meaning they only interchange positions. The mirror line reflects on both sides. The next one is reflection. Reflection in the line y equal to negative x. Y equal to negative x. All x negative, then y becomes positive. That's what reflection in the line y equal to negative x means. So y equal to negative, this is where y equal to negative is. So this is the line y equal to negative x. You have point A and then point B there. So if this is the mirror, then this particular point will be at this point, which is this one becomes negative, and this one becomes negative B. So therefore, if the object is AB, therefore the image will be A minus B minus A. You can see now both change the sign, and they also interchange positions. So minus B and then minus A, reflection in the line y equal to negative x. The next one is reflection in the line x is equal to k, where k is an integer. That is, reflection in the line x is equal to k. Now reflection in x is equal to k, where k now is an integer. K can be negative, 0, or positive numbers. So let's assume we have this particular shape. Let's say we have this triangle. Let me just draw a triangle here. Let me call this one A, and no, minus 2. This one minus 1. And then, no, minus 3 here. And then we have minus 2 in between. And then this one we have 1. And then here, 2. Just picking examples. So, call this one ABC. ABC. I want to reflect this object through the mirror line x is equal to 1. So this is my mirror line. This is my mirror line. This is my mirror line. X is equal to k. Therefore, this k is 1 here. X is equal to 1. So k is the same as 1 here. So meaning there are two ways. One way is you can count. You count the boxes, or you can use the general formula. For example, the distance from A to the mirror is how many units? The distance from A to this y-axis is 3 units, and then you add 1, you have 4 units. So from the mirror, and then that way, you will move, you add plus 4 steps. So therefore, that one becomes 5. So let me assume this is where 5 is. There will be no change in the y. So we have 1 there, so this one becomes A prime. The distance from B to the mirror line, you have 1 plus 1, you have 2 units. So 1 plus 2, you get to 3. So this is where 3 is. We call this one B prime. And then the next one, we have 2 units. To the mirror is 3, and then you move 3 that way. So 3 will be the same as, so this one I said we have 3 units. 3 units. So the next one will you move to 4 now. So this is where 4 will be. So this is my C prime. You join the points like that, the points like that. That is by counting method. We can use the general formula again. if, for example, this is a reflection in the line x is equal to k, the formula will be, if the object is AB, then the image will be, A prime will be 2k minus A, comma B. 2k minus A, comma B. You can check one of these. Let me try and prove whether this formula is correct. So the object, therefore, we have minus 3 positive 1. The A prime will be, this is A prime will be equal to 2 times K. The K is 1, so 2 times 1. And then minus, bracket, we have minus A, therefore you have 3 there. So minus 3, and then comma B, comma 1. I'm just checking the formula whether it is correct. So therefore this is 2 plus 3, that is 5, 5, 1. So A prime will be equal to 5, 1. And you can see now A prime is 5, 1. So that is reflection in the line x is equal to k. The same happens to reflection in the line y is equal to k. So the formula for y is equal to k will be, if that is the object AB, then the image will be equal to A, comma, 2k minus B. These are now the general formulas. You can as well use the counting techniques or the counting methods. So that is now reflection. The next one will be moving now to rotation. Rotation. These are examples of reflection. So let's start now rotation. Rotation, that is. Rotation is a type of transformation that turns a figure about a point or a line. So in rotation, we consider 3 things. Rotation, we consider 3 things. Rotation, we consider 3 things. That is, 1, angle of rotation, sense of rotation. Sense here, I mean direction, and then center of rotation. Center of rotation. So like from there, you can see we have that triangle. It is rotated clockwise at an angle of 90 degrees. At an angle of 90 degrees. So you can rotate an object through 90 degrees, then 180, then 270, then 360. If you rotate an object 360, it will come back to its own position. So therefore, each will be now, I'll be giving you examples on rotations, each. So the next one, these are examples of rotation. Then lastly, we'll be now discussing enlargement. Enlargement. Enlargement is a type of transformation that either increases or decreases the size of an object. So scale factor, by a scale factor, the scale factor can be greater than 1. The scale factor can be less than 1 but positive. Less than 1 but positive. And then the scale factor can be negative. So if the scale factor is greater than 1, the characteristic, one of the characteristics for scale factor greater than 1 is, this one is characteristics. Characteristics for scale factor greater than 1. Greater than 1, the object will be smaller than the image, meaning the image will be bigger than the object. The image, now from the diagram you can see, enlargement is also known as dilations. So the first star is smaller than the second star, meaning the second star is the image, the first star is the object. The first one, you can see now the object is now bigger than the image, meaning it is a scale factor that is less than 1 but positive. And then the scale factor, this one I said the image is bigger. The image is bigger than the object. And when it is less than 1 but positive, we said the image is smaller. The image is smaller than the object. The image will be smaller than the object. And when the scale factor is negative, therefore this one, the image becomes inverted. The image now becomes inverted. The image becomes inverted. Now, if for example you have a triangle, Let's say you have this triangle, and then this is my center of the enlargement, and I multiply by a scale factor. You can see now this one, the image. You can see now this one, the image is bigger than the object. The image is bigger than the object. And if you multiply this one by a scale factor half, the image now becomes smaller. Yeah, the image becomes smaller than the object. The image becomes something like this. So therefore, we'll be now doing some more examples on this.